Okay, so this video is a introduction to integrals, chapter 5. So we've done derivatives, and now we're going to get going on integrals. But first I want to recap what is a derivative. So it's really important that basically the derivative finds the slope doesn't have to be curved, but the derivative finds the slope of a curved line. So to remember, we have a random squiggly, and so then what I want to do is if I want to find the derivative, if I want to find the slope at that point, well, what I'm going to do is I'm going to zoom in on that point, and I'm going to find another point really close to it, and I'm going to say I've got x and f of x, and then I've got zoom out just a little bit. And I've got, so I got 2 points really close to each other. And because the points are really close to each other, there's approximately a straight line between them. And so then what I do is I zoom out. Too far. And what I'm going to do is I'm going to say the derivative of that function, which is also equal to the slope of that function, is going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. So that's my definition of what we're doing. Is I got 2 points that are really close together, and so then that allows me to find the slope at that point. But then, as we sort of learned through chapters 2, 3, and 4, there's all kinds of tricks that you can use. So you can say, basically, you can get really fast, and you can say, oh, well, if you've got y equals x squared, there's the power rule trick, dy dx equals 2x. And so that's the slope of the function y equals x squared. Okay, so then there's all the tricks, and I'm not going to go into all the tricks because we're moving on. So the next thing that we want to do is we want to find area under a curve. And that is the integral. So just like, so slope the slope of a curve is the derivative. The area under a curve is the integral. So then what we're going to do is we're going to come back with another squiggly. My good old sort of cubic squiggly. And I want to know, what is this area in here? Well, what I'm going to do is I'm going to break it down into a series of boxes. And if I zoom in, we're going to get into this a little bit later. Okay, this box here, I'm going to assume that it's basically rectangular. I'm just sort of getting into these details later. And what I'm going to do is I'm going to say that this box has a height of f of x, and it's got a width dx, and so it has an area of f of x times dx. So this box has a width. Height times width is the area of a rectangle. So f of x times dx gives me the area of that one right there. Okay, so zooming out again. That's not going to give me the whole area. That's just going to give me a tiny little bit of the area. So that gives me a little tiny bit of the area, so I'm going to call that D area. So I'm going to say area equals A, and so I'm going to say that D of the area is equal to f of x times dx. An infinitesimal tiny amount of area is equal to the height of the box times the width of the box. Now, my approximation gets better as dx gets closer to 0. Now, to find the total area, add up all the boxes. So what I do is I find that area and add it to that area and add it to that area and add it to that area, that area, that area, that area, that area, etc., etc. And you go, well, this would be really time consuming. It would be very time consuming if we didn't have two things. So what we're going to do is sort of old school. Just like we had tricks for the integral, or I'm sorry, just like we had tricks for the derivative, in a few videos we're going to have tricks for the integral. In fact, I'll give you a couple of tricks probably before this video is out. And sort of new school, tell a computer to do it. New school is tell a computer to do it. Isaac Newton, basically, there's Okay, so there's the pre-Newton school, which is you sit down with a pencil and paper for many hours. Then there's old school, which would be Newton and Leibniz, who basically came up with tricks that are going to work, but they're going to be limited to a certain number of functions. And then there's new school, which works on basically any function that you can type into a computer, which is basically you tell the computer to do it. Because computers are just happy to do computations. That's what they do. You know, it's like Bender bends, computers compute, right? So what you do is you say, hey, calculate this f of x and multiply it by dx, and then calculate that f of x and multiply by dx, and calculate that f of x and multiply by dx, and keep going. But, you know, actually I really want you to do it 5 million times. And by the time that you've completed your instructions, the computer has said, okay, it's done, and it spits out an answer for you. Okay, so I think that's about what I want to say for right now, and then I'm going to go over to my graphing calculator and show you some stuff on the graphing calculator related to this.